guys, Travis Legleiter, Extension Lead Scientist at the University of Kentucky. And today what we want to talk about is we want to talk about some different nozzle types and how they influence droplet size. So we know as far as when we make our spray applications with herbicides, droplet size has a big influence on a lot of different things. Not only including drift, which is the thing we're most concerned about, but also coverage as well. So the bigger we get our droplet, the less coverage we get. Now there's some differences in the amount of deposition we get, or the deposition isn't as affected as much by droplet size. But the big thing I want to focus on today on droplet size is drift and how far we might drift potentially with some of these droplet sizes, and focusing in on nozzle types and how those nozzle types influence droplet size. So we're going to look at 4 different nozzles today, from a single stage flat fan nozzle up all the way up to a 2-stage air induction nozzle, or the TTI nozzle. So first of all, we'll talk about the XR nozzle, or it's the extended range nozzle. This is a nozzle from T-Jet. You can also get multiple other nozzles from other manufacturers that are single stage flat fans, or just flat fan nozzles. And what those are is just a single stage nozzle that has one orifice. So this is important because that single orifice has 2 jobs. It meters the amount of product that comes out. So that's the size of it. So an O2 nozzle gives you 0.2 gallons per minute at 40 psi. An O4 gives you 0.4 gallons per minute at 40 psi. So that's the first job it has. The second job that that orifice has is it creates that fan, the fan that you see as we spray out these nozzles. And that's the second job. So with these single stage nozzles, we're doing both of those jobs with one orifice. Okay, so that's why it's called a single stage or a single step nozzle. When we do this, these nozzles are great because we can run them anywhere from 20 up to 90 psi, so we have a large pressure range. But as we change that pressure, we also change our droplet size. Lower pressures, you get a little bit larger droplet, and higher pressure, you get smaller droplets. So they're really prone to pressure changes. And so as we speed up or slow down in the field, if we don't have a pulse width modulation system, that can cause our droplet size to change. And overall, just that single stage type of nozzle, we overall end up just with an overall smaller droplet spectrum, and a droplet spectrum that's just a little much smaller, as well as many more driftable fines. So at this point in time, we'll take a look at the different droplet sizes, or the droplet spectrum that comes out of the single stage flat fan nozzle. Okay, now we're looking at the single stage nozzle, and with this nozzle, you can see there that we're getting some smaller droplets coming out of this nozzle. We are running at 40 psi on these. And these are the 11004 XR nozzles, so an O4 nozzle, a larger nozzle, but you can see here we're still getting a lot of small droplets out of this and a lot of driftable fines. So out of this particular nozzle at this pressure, we're probably getting upwards of 20% driftable fines out of this. And for now, let's just look at the way this breaks up. Right at the top here, you can see that sheet of liquid coming out, and it's the air resistance that causes this to break. So as we increase the pressure on the system, the sheet breaks quicker, causing you smaller droplets, and as you lower the pressure, you get larger droplets because the sheet's not breaking as quickly because it's not hitting the air resistance as fast. But the overall thing we want to look at here is that we do have a smaller droplet spectrum, and you can see a lot of these droplets will end up drifting off site with just a little bit of wind. All right, now we're going to look at a 2-stage nozzle. So this nozzle that we're looking at now is the TT-11004. So it's a Turbo T. Again, it's from T-Jet. With this nozzle, you have 2 orifices, or a 2-stage nozzle. So the last one we talked about 1 orifice, this one has 2. So what we've done is we've broken up those 2 jobs into 2 separate orifices. So you have the pre-orifice, and that is, if you look into the top of that nozzle, you'll see a small hole, and that is the pre-orifice. And so the only thing that orifice does is it meters the amount of product that comes out. So that's the size of your nozzle. And then you have an exit orifice, and that exit orifice is only responsible for creating the fan pattern. When we separate the 2 jobs and have 2 orifices rather than 1, and in this particular nozzle we also have 2 90-degree turns between those orifices, or a turbulence chamber, what this allows for is it allows our nozzle to operate 2 different orifices and allows for an overall larger droplet spectrum. And the other thing is, as we change our pressures from high to low, or from low to high, we're not changing our droplet spectrum nearly as much. Now, we still do change our droplet spectrum with pressure with these, but not to the extent that we do with the single stage nozzles. And overall, by having a 2-orifice nozzle, we have an overall larger droplet spectrum and less driftable fines. So let's go ahead and look at that. So here you can see the 2-stage nozzle. This is our TT 11004 nozzle. Again, an 04 nozzle. Again, we're running at 40 psi. And on this one, again, you can see that sheet there that is breaking up. The sheet that's breaking up breaks up a little bit differently than what you see with that single-stage nozzle. But overall, the thing I want you to notice here is overall, same size nozzle, same pressure. Overall, we're getting a larger droplet spectrum, but also the driftable fines coming out of this are much less. Now, it's still an amount that's unacceptable for a product like dicamba or anything we don't want to drip. You're still probably getting 10 to 15% driftable fines out of this nozzle, but overall, you get a larger droplet pattern or droplet spectrum out of this nozzle as compared to that single-stage nozzle that we looked at before. Okay, now the third nozzle we're going to look at is an air induction nozzle. So the nozzle we're looking at today is an AI XR nozzle. So again, this is from T-Jet, and what this has is air induction. So it's also a 2-stage nozzle. So just like the last nozzle, it has 2 orifices, those 2 separate orifices that do 2 different jobs, but also you have air induction. So what these nozzles do is they have air vents on them or air ports on these. It's right at the bottom. Some of your other air inductions, they might have holes in the side, but basically what this is as the fluid from your spray mixture moves through that pre-orifice and into that nozzle, they pass by these vents and they pull in air, and you have a mixing chamber where we mix the liquid and the air together. And what happens is as you come out of that exit orifice with that air and liquid mixture, you get an overall larger droplet spectrum. And when we look at this, you can see the difference in the way the sheet breaks up as compared to a non-air induction nozzle. So we're pulling air into the mixture, and what that does is it gives us an overall larger droplet spectrum, but also a more consistent droplet spectrum, and these are a lot less prone to changes in pressure than our last 2 nozzles. So let's go ahead and look at that. So here is the air induction nozzle. So this is the AIXR 11004 nozzle, and you can see we're running at 40 psi again, so we're keeping the pressure exactly the same, the size exactly the same. And again, if you look, you can see how that sheet, it looks different in the way it breaks up, and overall, when we break up with this one, the breakup is into larger droplets, an overall larger droplet spectrum. And the other thing is we have more consistent droplet sizing out of this by using that air induction. But the big thing is we really reduce our driftable fines by using this air induction technology. Overall, with this droplet spectrum or this nozzle, we're getting down around 5% driftable fines, maybe a little higher, maybe a little bit lower, but a pretty good reduction in driftable fines out of this nozzle using the air induction technology. And the other thing that's really nice about this nozzle is we can run it from about 15 or 20 psi all the way up to about 70 psi. So we have a large range of pressures we can run this nozzle at, which is really convenient because our original air inductions, we are not able to do that. Here we have our last nozzle, and this is the TTI 11004 nozzle. So this is a nozzle that many of you may be familiar with, especially if you sprayed dicamba in the past. This is one of the nozzles that has been promoted highly for it. And the reason for that is because it does not produce a lot of driftable fines. We can get below 1% driftable fines with this nozzle. And what this nozzle has is this nozzle is using, it's a 2-stage nozzle. It's using air induction, but it also has that turbulence chamber that we saw in that Turbo T earlier. So that's the 2 90-degree turns between the pre-orifice and the exit orifice. But you also have air induction in there as well. And when we include all of this into one little package, we get a nozzle that produces massive droplets, droplets that we certainly wouldn't want to use with a contact, but with the systemic herbicide that we don't want to drip, this is the type of nozzle we want to go with. So we'll go ahead and start looking at this. So here is your TTI 11004 nozzles, and you can see almost immediately how much larger and how dramatic those droplets are and how much bigger they are. Most guys have referred to them as bowling balls because they're so much bigger than what we see out of most of our nozzles. And you can see the majority of those droplets are in that ultra coarse spectrum. They're very large droplets, and you don't see a whole lot of driftable fines coming out of this. Again, you're only going to see about 1% driftable fines. And if you compare this back to that original XR nozzle, or a single stage nozzle, the size is very dramatic. Huge droplets here. The biggest droplets we're ever going to want to use within our broadcast applications, but droplets that we certainly don't have to worry too much. If we're spraying the right weather conditions, we don't have to worry about them moving off target. So this is the TTI 11004, the largest droplet we're going to have using air induction, two-stage, as well as a turbulence shaver, giving you a very large droplet. So that is a demonstration of our different nozzle types and how it affects our droplet sizes. So picking the correct nozzle can go a long way in giving us the correct droplet size, not only for drift reduction, but also giving us the correct coverage depending on what type of product we're spraying. So today we're showing you nozzles for herbicides. There's some different ones that we might use for a fungicide or an insecticide. But again, here's 4 examples of nozzles that we use for herbicides and the differences in droplet sizes that they give us between those different nozzle types.